Hello everyone, welcome to the new video of Automata and Computability. In this video, we are going to design a NFA which accepts all the binary strings having even number of zeros or number of zeros divisible by 3. So to design this NFA, we will at first build two individual NFA, one for even number of 0 and another for number of 0 divisible by 3. And then we will combine those two NFA to have the single NFA accepting both of these cases, right? So let's at first build the NFA for even number of zeros. So to do this, we will need two states, right? One state for even 0, and another state for odd 0. Now you can see that this even 0 will be our final state, right? Okay. And as the condition is on number of 0, so the number of 1 doesn't matter. We can have as many as 1 as we want, right? So for that we will have a self loop for symbol 1 in both of these two states. But if we get a 0 from this even 0 state, then we will go to the odd 0 state, right? Why? Because even plus 1 is odd. So when we get 1 0 from even 0, then the number of 0 will become odd. And similarly, from odd 0 to even 0, if we get a 0 from odd 0, right? So that's the NFA for even number of 0. So let's name these two state as state A and state B. So now let's design the NFA for number of 0 divisible by 3. So for that reason, as the number of 0 is divisible by 3, so there can be 3 possible modular, right, or 3 possible remainder when we divide the number with 3, right? The possible remainders are 0, 1 and 2, right? So we will have 3 state. So we will have 3 state. So this is remainder 0, remainder 0, remainder 1, remainder 2. So now we can see that the number of 0 is what matters. So the number of 1 doesn't matter. So for that reason, we will have a self loop of 1 in all of these 3 states, as the number of 1 doesn't matter in our question. So now, as this is remainder 0, this will be our final step, right? So let's give the transitions of 0. So from remainder 0, if we get a 0, that will go to the remainder 1. And similarly, from remainder 1 to remainder 2, if we get 0. And from remainder 2, if we get another 0, then the number of 0 will be again divisible by 3, right? So we will move back to the remainder 0 state with 0. So this is state C, this is state D, this is state E. So now we have the two individual NFAs. Now we have to combine these two NFA into a single NFA. So let's do this. So for that reason, we will at first need a start state. So let's have state F as our start state. So now what we will need to do is we need to connect these two start state of these two individual NFA with our new start state with the transition epsilon, with epsilon transition from new state to the old state. So this will merge this to NFA. So that's it. Thank you.